start a new chapter in terms of topic on what we call the firm theory. Now, firms are very simple-minded because they have only one objective, that is to maximize profit. Profit, we use pi as a symbol. So all firms, they are getting into business simply because they want to maximize profit. And we know profit equals to revenue minus cost. So total revenue minus total cost. And what we are doing today in chapter 11 is to take care of the cost component in the profit equation. Because it doesn't matter what kind of firm you run, you always have the same generic characteristics about the cost. And then after this chapter, 12, 13, 14, and 15, we will be focusing on revenue. Because how much revenue the firm can get when the firm sells its output depends on market structure, i.e., how much market power will the firm have. So if the firm has more market power, like Apple, selling its iPhone, a lot of people would like to buy the iPhone. That's why Apple, selling the same number of iPhones, will be able to charge a higher price than other cell phone companies. So more market power, more capable to charge more. So today we will be focusing on cost. And now, cost. A firm running its operation. So what firms do? Simple. Using inputs to produce outputs. This is what firms do. And using inputs, it will cost the firm money. Buying inputs will cost the firm money. But selling output, the firm can generate revenue. When you compare cost and revenue, that is the profit. And now, how much cost the firm would have to pay depends on how efficient the operation. The more efficient the operation, the lower the cost for the firm to produce a given level of output, and the lower the cost, the higher the profit. In other words, to understand cost, we must first understand productivity. Because productivity is related to efficiency. The more productive an input, the more efficiently used that input will be in the process of the operation for the firms. All right, this is the basic concept. Productivity is the driving force about the cost going up or down. And now, we separate the time horizon into short run and long run. Now, in economics, we do not separate or define long run or short run based on calendar time. Calendar time to us is irrelevant. So how do we define long run or short run? Long run means firms have enough time to make necessary adjustments on all its inputs. So long run means the time frame is long enough so that the firm will be able to change all the inputs in its production process. Short run means firms only have enough time to make necessary adjustments on some of its inputs, not all, because the time is not long enough. The time is too short. Firms would not have enough time to change all. They will only have enough time to change some inputs, and we call that short run. So this is how we distinguish short run and long run. That is, whether the firm is able to change all of its inputs or not. And now, inputs, outputs. The firm using inputs and through the transformation process it transforms the inputs into outputs. So which is like a bakery. They take the flour, butter, sugar, egg. These are the inputs. And then mix them together, put it in the oven, and you get bread, the output. This transformation process captures the input and output relationship is what we call the production function. Production function captures the relationship about inputs and outputs. That is, how inputs is being transformed into outputs. And now, inputs. Now, in general, we use two inputs. Because if this model works for two inputs, then it will work for any number of inputs. Reason why we choose two, because our paper is only two-dimensional, and we want to draw the graph to demonstrate the idea. And the paper is two-dimensional, so it limits how many inputs we can explain using this model. That's why we get only two. And the two most important inputs, labor and capital. Workers and machines and factories. So capital typically you can think of as the machines and factory buildings of the firm. Labor input, workers the firm hires. And now, when we have these two inputs, then in the short run, capital is fixed. Labor is variable. Remember, short run means the firm does not have enough time to change everything. If the firm is only using two inputs, capital requires longer time to change. That is, you can change the amount of labor input easily. You can hire workers and fire workers, or ask the workers to work overtime, only in a week. But you cannot build a new factory in 1 week. You cannot get a new machine in place and become productive in 1 week. And therefore, when we have limited time to adjust our inputs, usually we can only adjust labor inputs, not capital. In other words, in the long run, both capital and labor, they are variable, because you can change both labor input and capital input in the long run because you have enough time to do so. So when we look at the distinction between short run and long run, obviously the short run analysis will be much easier because we only need to concern about labor input. The capital input is fixed. You can think of that as you are being a factory manager. You are hired to run the factory. And when you are hired, the factory is already there. It's fixed. So all the decisions you need to make about output is to decide on how much labor input you want to use. So in the short run, it actually becomes one dimension, where we only need to worry about labor input. That is, you want to change output, only possible if you change labor input. So that's why we're going to start with the short run analysis, because this is easy. We only need to worry about labor input and output relationship. So now, in terms of labor input and output, the production function tells us how much output you can produce when you have this much fixed capital, but you can vary the labor input. K bar means fixed capital, like a given factory size. So in the short run, this is what the production function looks like. It's like a bell shape, but we cut the bell shape in half. So how do I know this is what the production function looks like? Now in the textbook, you only see this part. You don't see the full picture. That's why I don't like that part in the textbook. Now keep in mind, this production function is with the given fixed capital or factory size. And down here, this is quite flat. This production function, that is how much labor input you use and how much output you can produce, this is flat. That means increased labor input, not much increase in output. Why is that the case? Because for any given factory size, too few labor inputs, you are underutilizing that factory size. If you underutilize the factory size, that is inefficient. If you have 50 machines in your factory and you hire only 5 workers, the 5 workers cannot manage 50 machines, and therefore their productivity will be low the increase in output will be small. That's why it is flat. Same here at the top. At the top, increase in labor input, not much increase in output, because for the given factory size, you have too much, the opposite, too much labor input. You overutilize that factory size, i.e., also inefficient. In the beginning, you do not hire enough labor input to make the full use of the given factory size, result in inefficient output. In the end, up here, for the given factory size, you are hiring too much labor input. Like 50 machines, you hire 5,000 workers. So on average, 100 workers will be standing around one machine. This would not be productive. And now, in the middle section, this is steeper because increased labor input, you get more increase in output because you are now better utilizing that given factory size. And you are improving efficiency. That's why that curve is steeper. All right? So this is the general idea, the intuition, why the production function in the short run is like a half bell shape. Next, some technical issue. We said earlier, productivity implies efficiency. And efficiency, productivity, are related to cost. In other words, when the productivity improves, the cost will come down. The same as saying improving efficiency, it will help lower the cost. Then, before we know how to talk about cost, the first thing we need to do is to figure out how do we measure productivity. So now, let's learn about how we can measure productivity. The first measurement about productivity is what we call average product of labor. Output divided by labor input. This is the ratio of total. This is the total output you produce, and this is the total labor input you use. So average product of labor is the ratio of the total. In other words, if you hire 20 workers in your factory and you can produce 100 units of output, then on average, each worker is producing 5 units of output. That is the average productivity of each worker. The second measure about productivity is the marginal product of labor. The change in output over change in labor input. And this is the ratio of changes. For example, if you increase 2 units of labor input, like you hire 2 more workers, and you can produce 8 more units of output, then each additional unit of labor input will contribute 4 units of output in the end. So the marginal product of labor is a ratio of changes, telling us at the margin, if you increase 1 unit of labor input, how much output that extra unit of labor input will contribute in terms of output. So learning about these 2 definitions, now we're going to figure that out using our production function in the short run. So this is the production function based on given factory size, and we can change labor input. So the trick is find a point on the production function, and this is the labor input L1. And we can produce the output Q1. And therefore, average product of labor 1 equals to Q1 over L1. Total labor input and the total output you produce. And if we draw a straight line from the origin to this point, what do we see? The slope equals to rise over run. The rise from 0 to Q1. The run from 0 to L1. In other words, that is the average product of labor. So the slope of the straight line from the origin to this point of the production function is actually showing us the average product of labor. As we talked about earlier, this is relatively flat. The slope is small, and therefore, on average, the workers would not be productive in the beginning because we underutilize the given capacity of the factory. But when we hire more labor, like at this point, using labor input L2, we produce output Q2. Then the average product will be higher than the one that we had earlier. Because this one, the blue line is steeper. Steeper means larger slope value. Larger slope value means higher average product of labor. So what we see is, at the start, as we increase labor inputs, the average product of labor would rise. As we see from the red line to the blue line, the slope is getting larger, it's getting steeper. That means increasing average product of labor. Until we hit this point. This point, LA, and output QA. This is the maximum average product of labor. Because this is the steepest slope from the origin. The straight line will be able to touch this production function. So this is the level of input that will give you the maximum average product of labor. And after that, if you look at this point, then the slope of the orange line will be coming back down. All right, so let's get a clean graph to summarize our result. So, labor input, output. Labor input, average product of labor. The production function. We said earlier, this is the maximum. LA. And this slope is the maximum average product of labor. So to the left, as we increase labor input, the average product of labor improves. And then it reaches the maximum. And if we continue to increase labor input, the average product of labor will drop. So now we can connect that to the graph below. As we increase labor inputs, the average product of labor will rise. And it will reach the maximum here. And beyond that point, if you continue to increase labor input, then the average product of labor will decline. So the average product of labor curve down here is like an inverted U shape. You turn the U upside down, it will start to increase and then reaching the maximum and start to decrease. So now we learn about the property or the shape of the average product of labor. Next, we try to figure out the marginal product of labor. It also comes from the production function in the short run. So the definition, marginal product of labor, change in output, change in labor input. Well, change in output is a rise or fall. Change in labor input is a run, left or right. So again, this is telling us about the slope. But this time, it is the slope of the production function itself, not the slope of the straight line from the origin, touching the production function. So now, look at this part. Start off flat. That means low marginal product of labor. Flat means small value for the slope. The slope is the marginal product of labor. So start from the beginning. Because of the flat slope, the marginal product of labor is low. But increased labor input, the marginal product of labor is increasing. Because the slope is getting steeper and steeper. As we move from the beginning, somewhere along this middle section of the upper slope, the marginal product will keep on increasing until it hits somewhere in here, what we call the point of inflection. In other words, the turning point. That means at this point, with this much labor input, you are getting the maximum marginal product of labor. It keeps on rising, and then it reaches the maximum. After that, everything goes downhill. As you can see, it is now getting flatter and flatter. That means the increasing labor input, marginal product of labor will decline beyond that point. Now, let's get a clean graph to show this relationship, like what we did for the average product of labor. Labor input, output, production function. Labor input, marginal product of labor. Somewhere along here, you get the point of inflection. This is where you get the maximum marginal product of labor. Start from the beginning. As you increase labor input, marginal product of labor will increase because the slope gets steeper. So this is what we see. The marginal product of labor increasing. And then it will hit the maximum. And beyond that, if you continue to use more labor input, marginal product of labor will drop when the slope gets flatter. If you go in this direction, that is, the marginal product of labor will drop. So the marginal product of labor is also an inverted U-shaped curve. And now we have a problem, because the average product of labor curve is a U-shaped curve. Inverted U-shape, like this. And the marginal product of labor is also inverted U-shape. So where do these two curves stand relative to each other? Which one is higher, which one is lower? And at what point will they ever cross? To figure that out, we need to understand the relationship between marginal and average. The relationship between marginal and average. If margin greater than average, then it will bring up the average. If margin equals to average, the average remains the same. If margin is less than the average, it will bring the average down. So this is the typical general relationship between marginal and average. Now, how can we prove it? It's easy. Let's look at the first condition here. Now, suppose we have a wrestling tag team, 300 pounds, 400 pounds. The two guys on this wrestling team. And then the average of these two tag team members is 350. And now, we have a marginal or new member. This guy weighing 500 pounds. So now, with this additional marginal member, this new tag team, the average is now 400 pounds. And therefore, when the margin is greater than the average will go up. Simple numerical example, we can easily prove the marginal and average relationship. Now, this is extremely useful because we will use this several times today. So, how do we figure out the relative position? Labor input, average product of labor, marginal product of labor. So let's put the average product of labor curve down first. And then we ask, if we're going to put the marginal product of labor, where will it sit relative to the average product of labor curve? And what do we see in here? Is that average is rising. When the average is rising, it implies the marginal must be greater than average. And then, at this point, the average is maxing out, i.e., it is not changing. And therefore, same average implies the margin must equal to the average. Now, based on these two arguments, we know the marginal product of labor will look like this. On the left-hand side, marginal greater than average. That's why the average is rising. And it will go through the maximum point in here, because at the maximum, average is not changing. And to the right, obviously, now we have falling average. Falling average implies the marginal must be less than the average, which is why the marginal product of labor curve is below the average product of labor curve. So, using the relationship between marginal and average, we can now settle the questionable position scenario. That is, which curve is above, which curve is below. Using this simple relationship between marginal and average, we can figure out the position of these two curves. And now, next. Average product of labor. We figured that out. and we set productivity goes up, cost comes down. And how can we prove this relationship? So to prove this relationship, now we need to go into the cost definition. In the short run, the short run total cost total cost equals to how much capital you use plus how much labor input you use. Remember, using input will cost you money. Capital, we use R. Labor, we use W. Why? Well, because firms usually borrow money to buy machines. And therefore, for the machines they borrow money to buy, they have to pay interest. So the interest rate is like the cost of the machine to the firm. And this one is the wages. You pay your labor, your workers, with wages. So in the short run, this is what the short run total cost look like, because we are only using two inputs, and therefore the cost will only be based on how much of these two inputs you use. So the short run total cost equals to how much you pay to get the fixed capital and how much you pay to get the labor input. This is the fixed cost. This is the variable cost. Why? Because interest rate, wages are given, and capital also given in the short run. So in other words, this one does not change. It doesn't matter how much output you produce. So if you purchase a machine and you don't produce any output, you still have to pay for the price to buy the machine. So that's why it is a fixed cost. It does not vary with output. But this one is variable because labor input is variable in the short run. You can increase or reduce labor input, and this cost component is the variable cost. So now we learn this. Short run total cost equals to fixed cost plus variable cost. Then, average variable cost is the variable cost divided by output. That is, on average, what is the variable cost per unit of output? So this is what we call the average variable cost. And the variable cost equals to wages times labor inputs. So in other words, the average variable cost equals to wages times labor inputs divided by output. And if we divide the numerator by labor input and the denominator by labor input, it will not change the ratio. And this trick will eliminate labor input in the numerator. And in the denominator, that is the average product of labor. So in other words, the average variable cost equals to wages divided by average product of labor. And now you can see the inverse relationship between productivity and cost, because as the average product of labor increases, the entire ratio drops, and therefore the average variable cost will fall. So this is the inverse of negative relationship between productivity and cost that we talked about earlier. The improving productivity is going to help you lower the cost. All right? Next, we will connect the marginal productivity to its corresponding cost measure. So, short-run total cost equals to fixed cost plus the variable cost. If we change short-run total cost because we change output, and therefore the change in fixed cost when we change output, change in variable cost when we change output. This, on the left-hand side, is what we call short-run marginal cost. That is, producing one extra unit of output, how much would it cost you at the margin? Equals to this is 0. Fixed cost does not change with output. That's why we call that fixed cost. Short-run marginal cost equals to change in variable cost over change in output. Change in variable cost, that means change in wages times labor inputs over change in output. Wages given, and therefore change in wages times labor input is simply wages times the change in labor input. And short-run marginal cost becomes wages times change in labor input over change in output, coming from this line. And we use the same trick. That is, we divide the numerator by change in labor input and divide the denominator by the change in labor input. And that would help us get rid of the change in labor input in the numerator. And in the denominator, that is the marginal product of labor. And now we have to connect another cost measure to the to the marginal product of labor. That is, short-run marginal cost equals to wages divided by the marginal product of labor. the denominator gets larger, the ratio drops. That is, the short-run marginal cost will come down. So that gives us the negative or inverse relationship between the productivity and cost at the marginal measure. And now, let's summarize what we have done so far. From the total output in the short run, we get the marginal product of labor and the average product of labor curve. And we also demonstrate average variable cost is inversely related to average product of labor. Short-run marginal cost is inversely related to the marginal product of labor. In other words, our next step is to connect this graph to the marginal cost through marginal product of labor, and the average product of labor to the average variable cost. So what we see in here is that as average product of labor goes up, average variable costs come down, and vice versa. Falling average product of labor, rising average variable cost. Down here, rising marginal product of labor, falling short-run marginal cost, or falling marginal product of labor, rising short-run marginal cost. And now we have everything ready. When average product of labor is rising, then the average variable cost must be falling. And when the average product of labor falling, then the average variable cost must be rising. So based on this relationship, we can easily plot the average variable cost based on the shape of the average product of labor. And for the marginal product of labor, when it is going up, the marginal product of labor going up, short-run marginal cost is falling. When it is falling in the marginal product of labor, then the short-run marginal cost is rising. So this is why we must get the productivity graph first. Because once we get the productivity curve, we simply take the mirror image of the productivity graph, we get the two cost curve. That is the average variable cost and the short-run marginal cost. And there are two more cost curves in the short run. Let's take a 10-minute break first.